I think we're live. Give it a moment for Twitch. I have things on screen. I'm just showing the wrong stuff. But one button away isn't too bad. Make sure we have audio. We do. Beautiful. So I was here earlier. We just had a nice offline discussion. Boom. So today is March 26th, 2025. We're here in CSE598. And we're kind of poking around at Windows and seeing how we can adapt our kind of Linux understanding to a different operating system. So first and foremost, memes. So this first module that just wrapped up, honestly, people have mixed opinions of over the years. People have said, hey, it's super easy. And other people have said, hey, like I blew my leg off like over something really silly and just sunk a bunch of time in. So that's a good sign to me. It means that the module isn't too easy or too hard. First being, we saw me last week not understanding why the I/O for Pwn tools was doing what it was doing, but it turns out if I just passed something in, it behaved how I wanted, and so if it works, it works. This middle one makes me sad. I myself haven't experienced it because I do all of my work on a local dev environment. People are saying that the Windows is slower as of last week opposed to 2 weeks ago, and I don't know why. I changed stuff, and it should actually be faster. But I have no rhyme or reason as far as why the startup time for Windows Connect is slower, if it is, on the prod instance. It's just as fast for me and my local environment. So I would love to blame 365 students, but I don't think that's the case either. One of the things that we probably figured out in this first module is the Win32 API, and in fact, Windows as a whole is extremely verbose. The equivalent functions, to like open or even read, there are a ton more arguments, and it's a lot more complicated API. We're going to take a look at some of the complication and why that complication exists in a little bit here. But that is true throughout the entire system, right? And when you're trying to read this documentation, until you've done it for a little bit, it can be confusing. You see something that says optional, it probably is not optional, and this is true across a lot of things in Windows. Optional really just means hypothetically kind of sort of nullable if you're doing the right thing with the API. So this was our schedule. I'm not changing a lot. Instead of launching the new stuff here today, I'm pushing it till Friday. I'll probably shift that 4/9 to be our regular schedule, so we'll fall back on track to Fridays because that works so much better for me. Hopefully, it works better for you. You get your 2 weekends, and we'll see what happens there. Okay, demo plans. I think I answered most questions people had about the existing material beforehand. There is one thing that I think is worth showing. I mentioned it, but I didn't show it. And if Windows Connect takes forever, I'm going to go ahead and do that. Start this up. Ah, you are back. Twitch, it has been a long time. So I'll wait for the Windows VM to start up while I rant a little bit longer. Windows Connect. Okay, we'll see. That'll probably time out. But one of the things that we looked at last week was the stat canary. And the stat canary in Windows works a little bit differently because the stat canary, which they refer to as a stat cookie instead of a canary, consists of a different value for different functions. Nice. And the way that value changes is based upon RSP. And there is only one stack challenge so far. I have a couple more, but I decided not to release them because they're fugly. But off stream, the class said they want fugly challenges. So we might get to see a couple more stack related challenges. All right. So if I fire up WinDebug and we launch this PC, C challenge, baby win smoke test. Okay. Let's break at main. If we list modules, we have symbols for baby win smoke test. Hopefully, main has a stack canary, but the stack canary consists of this random value XORed with RSP. And one of the things that I mentioned that I guess people might not have caught was you can examine the random value. And it is located
It's double underscore.
right here. The statement from class was, I think it's double underscore, both actually. I don't know why, but it does. I think you're correct. It is double underscore, but it's got to find it. Maybe it does some fancy search, right? Great for the thank you, debugger. But we see right here that this is the random security cookie value that is getting XORed with RSP. And if we were to look at where in memory this is, I'm probably going to get this wrong, but I don't know that this is the correct command. Find out together. I think it's there. And there's a couple commands we can look at here. So if I run exclamation point address and give it an address, it's going to tell me roughly where it is. And then it gives me some additional commands that I can run. The one that I'm interested in, if I remember right, is this exclamation point DH, which is for dump header. And this is going to dump all of the header information from the PE file. And if we were to look at this and find the virtual address, what we would find is that the stack cookie value that I dumped out here, that I dumped out right here, the memory location where that value is written is early in the data section of the binary, right? That's why I had to specify that I was looking inside this module. It's the stack or the security cookie is getting stored in the data section of the executable while it's running in memory. And so that is something that can actually be accessed if you were to have like an arbitrary read primitive, right? Which is kind of interesting. Just as a quick aside.
Can you see the memory? Can you see the permissions of every memory? It's like in VMware.
So I'm not aware. I wish there was. I'm not aware of a super clean, like literal one-to-one with VM map. But that address command that I ran, it shows me, I gave it the address of this stack or security code, right? And it's showing me, hey, here's the region of memory where it's mapped, right? I gave it the address, just an arbitrary pointer to 19080. It says, here's the region that it's mapped, and it says that this is mapped to read write. And so I can't just, as far as I'm aware, I would love it if somebody could prove me wrong, of like a VM map command that just says, here's all of virtual memory. There probably is a command like that, but I don't know it. Well, what I can do is I can say, here's a memory address. Tell me about this region. And so this is interesting and hopefully useful in a future challenge. Okay. Did anyone have any other questions, comments on existing content? Jalen? Somebody said WinDebug is really slow. If WinDebug is really slow, you know what you should do? I did show this last week because I was pretty proud of it. Um, so CDB is mm, the command line debugger, right? This is literally the thing that is running inside your GUI command over here, right? So everything that you've learned right here that you could do, you can type right here. So we can again list our module. We can break it main. We can continue. We could examine. What did we just do? Examine at baby win smoke test. That module, security cookie, there's that value. I wonder if this one works. I haven't tested this. I would imagine it does, though. And we get that same experience. So if I have managed to convert you into being a terminal lover, this is available to you. However, you can't do the nice thing like I'm not in anything, but have the GUI, for instance, track the disassembly at the instruction pointer, or watch a particular region of memory and have that side by side, right? You lose some niceness that GUIs can provide, um, but we can do this. So I think that's something cool. All right. So if there is nothing else, I'm going to dry run a slide deck that I have for the upcoming material. It's not everything that's needed. It's one of several topics that we will kind of explore. And this first one is just kind of thinking about the Windows security model. All right. This will probably get re-recorded as a pre-recorded thing. But it makes sense to me to do this now ahead of time. And then if you guys are like, man, this makes no sense, I know what to fix in the future. I think with some of the pre-recorded stuff, I may have pre-recorded it and made it official a bit too early. I don't want to make that same mistake with this module. So I mentioned this, I think, off stream last week. But when we think about Linux, yeah, the off stream, candid talks. If you don't show up to it, man, you pay the price. So Linux, a lot of times we like to say everything is a file, right? And on Linux, this is a real thing. If I have a Linux terminal here, we can, for instance, look at what do I want? Proc self fd. Proc is the whole proc file system, right? Is this pseudo file system that the kernel exposes via procfs, which is a custom file system implementation that allows me to utilize the file system to learn about what's going on with my system. But this concept of everything as a file exists in other places, right? For instance, lsdev. This is the directory where devices that are located. So this is where, do I not see it? I don't see what I was hoping to see. I was hoping to see like in a dev SDA, which is typically, probably because it's a Dojo thing, but if you were on a local Linux box, you would have devices that are commonly named like dev SDA1, SDA101, there's some prefix there. Those are like your hardware devices that are plugged in. If you plug in a USB device into Linux, you can commonly find it here located in lsdev, right? And so the Linux kernel exposes a lot of information via the file system. And we can interact with these raw devices. For instance, if you wanted to wipe a hard drive or reformat a hard drive, the way that you can do that, one of the ways you can do that on Linux is by interacting with this file that exists on the file system, but it is actually a kind of a mapping to the physical hard drive device that is plugged into your computer. You will also find like RDEV or RSDA. So you can interact with a hard drive as a raw device, which is faster versus kind of a managed device. And so the file system is how we kind of abstract all sorts of different things. One of the things you might have seen that I don't, what is it? Procnet. You can connect over the network to something via the file system. Does anyone remember what that is? It's like net IP. I don't remember the path, but there is a path that you can access over the file system in the terminal or via anything else that initiates a network connection. You look it up; it's a thing. Um, and so Linux abstracts everything away into the file system in all sorts of like crazy ways, and programs can leverage the file system to surface that information in a more interesting way, right? Like if I were to type just PS on a Linux system, this same information is available via proc. I'm not saying that PS is accessing proc, but if you start looking at how some of these introspection tools work, a lot of the times, the way that they work will either be via a syscall or via something on the file system that's like a magic happy path that the system exposes. Oh, somebody thinks they have it in Bash. Okay, let's see if I can do it. So I would want to cat dev TCP server. This is not Windows, but it will be amusing if we can do it. Let's netcat. Let's listen on 1337 on localhost. Let's echo hello into dev TCP 127, or let's see if localhost works. Localhost 1337. Okay. Thank you, Twitch. That is what we're here for. So I couldn't think of what the exact path was, but yeah, via the file system, I just wrote to this particular path, and what happened? This connected over localhost to port 1337, right? And there's all sorts of cool little tricks that you can pick up and learn as you explore Linux, right? And a lot of these are involve interacting with the file system. And this is why on Linux we say everything is a file, because that is how we try and package all sorts of things that aren't files, right? Is via the file system, via some type of funky file. Windows, on the other hand, has a different philosophy. And I'm not going to say it's better or worse. It's different. Okay, the way that, and there's definitely historical reasons why this is the case. On Linux, each of these are like independent components that were kind of built in isolation, right? It's open source. If somebody wants to refactor how some part of the system works, it doesn't necessarily need to be a single cohesive system. But if you're going to build something that's closed source, something that's like a commercial product, it makes sense to have some standards, right? We aren't just a bunch of crazy people hacking away on a piece of code that we agree we're going to behave reasonably. Instead, we have standards and we have rules. And part of this idea of an operating system having standards and rules is that we can represent everything in a consistent manner, right? The fact that everything on Linux is a file, it's kind of a hack, right? If you think about it, like the way each of those work can be slightly different. But the Windows kernel, everything is an object. And this sounds like, okay, yeah, object-oriented programming. I've heard of this before, right? Well, I said things like open, give us a handle, right? And I'm like, handles are kind of like file descriptors. The difference is that in Windows, this concept of a handle, it expands to any type of kernel object, virtually anything, any type of resource that exists inside the system, right? Now, this is WinObj, which is a nice graphical tool that can show us all persistent objects that exist in Windows. Now, what I want to go to is this path right here, basic named. If I hang it down at the bottom, we should see things being added and created here. So there are objects for, we know what a semaphore is, right? They also have mutants, right? A mutant is really just a mutex. And you'd think a mutex and a semaphore functionally are the same thing. Windows does make a distinction between the two, where a semaphore is something that does have a counter that gets atomically incremented and decremented. Mutex is specifically there for mutual exclusion, right? But, the objects that we see here are persistent objects, which means these are things that are not a file being opened by a process, right? This is something that the kernel itself is saying, hey, I need to have this mutex, and it just needs to exist for the lifetime of the system. Now, this sounds a little weird, but if we were to look, devices are objects, right? Though on Linux, we have /dev/ all of these things are files. On Windows, the internal representation of everything is actually an object. So when we type something like, let's go to Windows here, LSC. From the way that the operating system kind of views things, C doesn't actually exist. C is a device that is an object that is mapped here. I should find it. Let's not refresh. Where did it go?
Maybe driver.
No, driver is kernel drivers. I would expect it to be. Oh, it's going to be in the global. There's C. This is the object that represents the C drive. And we see that it is of type symbolic link. So what we're looking at here is there's a component inside the Windows kernel that is the object manager. It is the central component that is responsible for keeping track of all of these objects. Not only these permanent ones, but also the kind of short-term ones when we ask for a handle to a file. We just don't see those objects from this view. And C isn't real. Instead, it is represented as, oh, I need to install something real quick because it's not yet NT object. Sure. It's not on prod yet. This is a PowerShell module that is going to do a lot of the heavy lifting for us so that we can look at and kind of abstract away some of these NT objects. And so WinObj allows us to see these kernel objects. Once I install this, we'll look at NT type and kind of see what it means to be an object. If you take an object-oriented class, like the general concept here shouldn't be too mind-blowing. But it expands to several elements of the system, so I think it is worth spending a little bit of time looking at what it is and why. So if I do get NT type, I think I want file. That is super exciting, right? This is that's not what okay, so this is the object of a file, or the type of a file. And every type has its own unique properties. Now, there's some things that are generic. Like we've seen things like generic read, generic write, right? This looks familiar. Read, write, execute, right? But the abstraction over this is totally different. If we want to see something that are objects that are not like global objects, we can use this tool here, Process Explorer. There is a fork of this that is also installed on the Dojo. I need to say view lower pane. Boop. And I'm going to go pick a process. Give me, let's open like Notepad. And if we scroll down, we can find this Notepad here. We look at handles. These are all of the objects that exist inside Notepad just for this one instance of Notepad. We see that there's 4 threads, right? Well, there's many sections. A section is shared memory. So as on Linux, we create shared memory and we map it into multiple processes. In Windows, the implementation of how the shared memory works, it's backed by a section object that we could get the type of, right? And that is the object that represents any shared memory that gets mapped into different processes. And so all of these things, you'll see that this isn't called objects in Process Explorer. It's called handles. So this idea of like opening a file and getting a handle, I open shared memory, I get a handle. I want a thread, I get a handle. I want a semaphore, I get a handle. Everything that you are doing, well, not everything, but a ton of what you're doing with the Win32 API is you are performing some type of system call to interact with or get a reference to this object that exists inside the Windows kernel. Key is just a registry key, just FYI. They're not particularly interesting as an object class, but they are represented. And then event is something that is just like a triggered typically in Linux, if we want to like synchronize things, we would use a semaphore, right? We create a semaphore, and Linux semaphores tend to live in userland, right? And so we create a semaphore in userland. I fork up another process. One is waiting on a semaphore. The other one increments the semaphore, and we have now reached the synchronization, right? In Windows, we don't explicitly need to wait for a semaphore. If it doesn't need to be like an atomic event, you can just wait on virtually any object. The generic kind of thing that is waited is an event. So you can create an event object, right? You get a handle for it, and you can wait on that event. We just call this event, something is done. All right, cool. We not only can wait on events, but we can wait on a thread. What does it mean to wait on a thread? Okay.
I'm still lost on waiting on an event.
Okay. It's fine. Like the rabbit hole goes a little deep here. So I create an event. Right? All objects, for the most part, have this property called signal. Right. So it's essentially in Linux how we think of mutexes. Right. It's either available and I can hold on to it like a lock. Right. Either I have it and you're stuck, or I let go and now you go. Right. That's still, that concept of literally using a mutex exists in the Windows kernel, but that's what the mutant is for, right? The mutant is the literal mutex. But what if, because in Windows programs, we tend to see a lot of threads, right? I just opened Notepad and we saw that there's more than that, right? Here's all your threads, right? And they're just doing whatever it is that they do. But these threads and this synchronization problem, and part of this isn't specific to Windows. It's that Windows tends to be more graphically oriented, right? When we're using it, almost everything that we've done on the Linux side happens on the command line. So we can have kind of these simple single-threaded things. But at a minimum, if you have ever done any type of like GUI programming, you typically have a draw thread that is dealing with rendering whatever is on your screen. And then you can have a background logic thread. Like at a minimum, you have like 2 threads going. And you never want to block your drawing thread. Like this is just general programming, not specific to Windows. And so at a minimum, you'll have 2 threads. And so the synchronization thing becomes a very real concern, right? But I don't necessarily need to have a mutex. It's not that I need something to be mutually exclusive, right? Only one thread accesses this region of code. That's the purpose of a mutex, right? There's some critical section where only one thread should be there. That isn't the problem I'm trying to solve. Like what happens if this is Process Explorer, but I click on this right here, right? I did something. That is going to trigger something to occur in the draw thread, right? The UI thread. That's all that thread's job is to just deal with whatever's happening in the UI. But then there's going to be some background threads that are the logic, right? Somewhere we have to pull this information and pass it to the draw thread. Maybe there's only one worker that does one working thread that does that. More than likely, on like any reasonably complicated program, you're going to have more than one thread working in the background. Okay. And so I don't want a mutex, right? I can't use a mutex to signal that this occurred, this click occurred, can't. I can't really use a semaphore because I don't have threads blocked waiting for someone to click on this exact button, right? Instead, it's just an event occurred.
Oh.
Right? And so you can have an event and it's just, oh, this happened, right?
Would there be an event for every possible action for the GUI?
So you don't have to abstract it that way. But the purpose of an event is it is something that can be waited on, right? It is an object that can be waited on, that can achieve a signaled state to indicate that some event has occurred. And I'm not even saying that you would specifically use an event for this mechanism, right? I'm just using this as a high-level abstraction of why an event matters, right? Because I may have like 5 threads that are waiting for some event to happen. Well, they're all blocked on this event object that I then say, hey, the event has occurred. Once the event has occurred, all 5 threads now can go free. So it's not a mutex and it's not a semaphore because I don't have to clear the signaled state of the object once I've observed it, right? So like with a semaphore, we think of it as a counter that starts at like 2, and every time you grab it, we decrement, we block at 0, right? But with this idea of waiting on an object, it is different terminology, and it's different terminology for a good reason. It's an object that is either in a signaled state or a not signaled state. I can observe that it is signaled without clearing that signal. Okay. And so an event is like this generic something that we're looking at to represent some action has occurred. I'm going to just keep clicking on the wrong tab up here every time. So all of these objects exist, and these objects are constantly getting created and removed. A object inside the kernel that is like a file resource would be a transient object because it is being held onto or created from a specific userland process, opposed to something like the C drive is a persistent kernel object that is just going to exist beyond the lifespan of any individual process. Right? But they are all objects inside the kernel that are managed by this object manager. Now, what I wanted to show here was I can get NT file, and then if we were to look at the help for this, it's going to tell us that we can specify a path. Right? Now, do you think if I'm trying to get an NT file that I can give it C flag?
What's NT again?
NT is the prefix for kernel things. So like when we talked about how the Windows API works, where am I? Windows Crash Course. One of these have slides, don't they?
First
In the
one.
post.
Bam. We talked about how it works like this, where as a user, we tend to interact with this wrapper Win32 API. That's where we get things like create file. And then there's the native API that exists underneath it. And it's represented by these different DLLs. So by convention, these functions are prefixed with different things to indicate what they are. So we call create file, which may or may not be create file A, or create file W if it's Unicode or not. Then that goes into the kernel base, which then calls into NT create file, which is the actual native API. When I say native API, I mean it is using the communication standard that the kernel actually uses, right? Remember when we looked at create file and the function signature was different than NT create file? Do you recall or not? If not, I can pull it up and show you again.
I'd appreciate that.
Okay. So we'll MSDN create file. Grab that one, and then we will MSDN NT create file. And this will be important in this module, so it's worth looking. So in the first module, you probably called create file, and you probably pulled this page to look at how do I set up and call create file in my shellcode, right? Well, what you were calling was some fixed address that went to this function, right? And this function was located inside kernel 32 DLL. This is where create file lives. So you were writing shellcode over here. It was technically executing your stack, which isn't there. But we were executing shellcode on the stack that then called into create file. And we just said, cool, we got to create file. As long as we follow the expectations of what create file is expecting for arguments in our shellcode, I don't have to care about what happens after this. We just rock and roll, right? But if we want to start understanding how Windows actually kind of functions, we need to get a little bit deeper. And that is where, well, what happens after our shellcode calls create file? It's going to jump into this kernel base DLL, which is not very interesting at all. It's essentially a shim. And then so it jumps us into NT DLL. NT DLL is where the actual syscall instruction is located. Do you recall me dumping that up?
Yeah.
Okay. And so this is where we would find inside ntdll.dll is where we would find the actual assembly instruction that is syscall. Right? And remember, syscall is where we actually do the transition from user land to the kernel. And so there's actually quite a bit of stuff that happens in between create file, which is kind of our userland friendly representation, and the arguments to the actual syscall. If I were to look at NT, which is the mnemonic there is it's the native API. Native API being it is the thing that goes to the native kernel. Right? There's other prefixes that you can see. You may see, for instance, ZW as a prefix to something. I don't know if there's a ZW create file. Let's find out. MSDN ZW. Oh, there is. Cool. So we now have 3 different functions that are all involved for creating files. All right, we have create file, which if you are a normal Windows programmer, that's all you need to know, right? I just set up things that are whatever create file says I need.
And if I remember right, this is the one that this is the implementation that does not change.
Correct.
The user, but Windows can change how NT create files works internally.
Yes. So the statement for Twitch was, this is a consistent standard that should not change. Like if it were to change, it would be a big deal, right? Microsoft, generally speaking, says this function will have this definition. And if we want to change how the kernel deals with files, that is not something you need to worry about, right? Because what happens in between you calling your shellcode calling create file and actually getting to the kernel, these 2 steps, Microsoft can change. They can do whatever they want, right? Because their deal with you is you just deal with create file. We deal with the rest of the pipeline. if we want to understand how Windows actually works, we have to take a look at, well, what is Microsoft actually doing, right? Now, the kernel-based DLL I only mention because it's there. It's not particularly interesting. NT create file is interesting. We saw here we have 3, 4, 5, 6, 7. If I look at NT create file, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I now have 11 arguments. And if we were to look at the types of these arguments, you would see that the types of the arguments to NT create file also differ. So like NT create file has, that's going to actually probably be the same. Project attributes.
Keyword here, access something.
Right, it's an access mask, which we'll actually talk about if we have time on the slides. But what is happening in between here and here is Microsoft is changing the representation of the call from whatever they promised you to whatever they want the kernel to actually deal with right now. Right? And that is where we get to NT create file. Now, I said that there's also ZW create file. The ZW prefix, this should be the same. Anyone? Looks the same, looks the same, yeah. It should be the same to us from outside the kernel, from in user land. These two are functionally the same. So if we see something that is NT and we see something that is ZW, we can treat them as if they're the same function. They technically are different functions. They're going to be different memory addresses, different call sites. But as far as what happens, if we call that from user land, we trigger the exact same behavior inside the kernel. The difference between NT create file and ZW create file has to do with if you are calling this function inside the kernel.
Oh, okay.
Right, but you can call this from outside the kernel
because
it's there, right? But
so what's the point of knowing that you've called the function from the kernel as opposed to not from the kernel?
So I don't want to go down this rabbit hole in particular today, but if we think about what we've seen in kernel stuff already on the Linux side, we care a lot about accessing specific memory addresses or being more concerned about what happens with memory because the kernel can't screw up. The kernel screws up, your entire computer locks up, right? And so when you are performing actions within the context of the kernel, there are additional things that you want to consider that you don't have to consider if you're in user. And we're just going to leave it there. I think it would be cool, and I hope that eventually this Windows content can get to exactly this kind of thing. But we're quite a ways away.
Well, there's no content for this yet.
There's no
content for dealing.
So in order for me to have challenges that would interact with this mechanism, I would have to write a vulnerable kernel driver that you would be exploiting to see the difference between these two, calling these two different functions. So if there is a challenge that does that, then sure. The only thing that we need to take away today is that from user land, calling either of these, they're equivalent, right? The arguments are the same. The behavior that we'll observe from user land would be the same. There's a couple other prefixes, but I don't remember all of them. They correspond to, outside of the NT, they correspond to different components or subsystems inside the kernel, is what these prefixes start to refer to. Just factoid. Okay. So everything's an object, stuff is crazy. Why make everything? Where was I?
We're in the middle of getting the object in the terminal.
I was.
This whole
Oh yes. Okay, this is what happens when we go off the tray. We'll finish this thought, and then we'll take our mandated break here. So if I want to get the NT object, the internal native representation of a file, internally inside the kernel, this isn't like a path. Instead, everything is an object, and so I can't refer to this. This isn't an NT object. I'm trying to create the NT file object. C doesn't exist, right? When we look at this Windows Manager guy, WinObj, which isn't the Windows Manager, but it gives us a view into it. We see all of these. If I want to reference C, it is actually in this global namespace. And so the kernel's terminology is a namespace. All of the objects exist in this object namespace. And this is the root of the namespace. And so if I want to reference or create a file object inside the kernel, I have to reference it via this namespace, which should be, if I want to get to C, now watch this not work. And you're just like, you did all of that talking, Robert, to say you have to put /question ? And the answer is yes, but it's very important to understand why this /question ? exists.
Is it because of the global
Yes,
question
this
mark?
is the beginning of the global namespace, or the beginning of the namespace. It's corresponding to this right here. My question mark gets me to this global namespace where when you see everything is a symbolic link, right? Because these are things that we just want to, generally speaking, reference. And it could be nested somewhere in here. I could find where C actually is in this namespace, but it makes a lot of sense to have I'm probably going to access the C drive or refer to it within the kernel pretty regularly, right? And so instead of having to know whatever the exact path is to find C, we say we're in this namespace. I want the global shorthand for C, which is actually pointing to device hard disk volume 2. So I could probably, this would be fun. Let's see if I can, I don't know if this will work. If my understanding is correct, we should be able to create a file that refers, or a NT file object that refers to the flag via /device hard drive disk volume 2 /flag. Because this is all going over this global name, or this namespace where all of these objects live inside the kernel. Hard disk volume 2. I don't think it's case sensitive, but did I misspell?
You have the question mark.
Oh,
Is it case sensitive?
hard disk volume 2. Can I do this? No. Dang. Oh, the device isn't capital. I still want to believe. All right. Dang.
I still think it should work.
Hard disk, capital V, volume 2. Huh. All right. So I guess that itself. Wait, can I do? Because C refers to.
Wait, is the symlink correct? There might be an extra thing.
Did I miss something there?
Like if you go to global,
Go back global.
Yeah,
We'll look for C.
is that the name? Yeah, it is.
Hard disk. Yeah, it's linking to device hard disk volume 2. Let's see. No. Dang. But internally, I'm not entirely sure how get NT file is parsing it, but I can tell you that the kernel is parsing it how I'm describing inside its object representation. So the kernel is looking for C inside the global namespace, which is this right here, which then grabs this symbolic link and follows it to device hard disk volume 2. And then that is how we get to the disk, and then we can talk to the component of the kernel that deals with the actual file system, the NTFS file system. And that gets translated from there. But the key takeaway here is like literally everything is an object. And we'll see why that matters, or why that kind of influences how Windows works after our break. So let's take our quick pause. All right, we returned. Everyone is refreshed. I swear they turn off the AC in this room when I get here. Sure feels like it. So Twitch asked, can these object symlinks be changed at runtime for like a time of check, time of use exploit? So you have to realize that the object manager is inside the kernel, right? When I look at this here, the reason that this thing, WinObj here, allows me to do stuff is because I started this challenge in practice mode. I am an administrator. This is an elevated privilege program, and it is allowing me to look at the namespace inside the kernel. And this isn't something that, and remember, this is a persistent store that exists outside of like the context of a running process. So it isn't something that I can typically interact with as an unprivileged user. The Windows security model is very interesting, and it's part of the kind of challenge building out this material and building out challenge content for you guys that is interesting. It's because their model is very different, as we'll see in the next couple slides, right? Because I keep saying, like, as an unprivileged user, and if you are a Windows user at any point in your life, you're like, well, I bought my Windows computer, I booted it up, I made my account, my name's Rob, and I can right-click and be an admin whenever I want, right? And that's true on people's like consumer desktops, right? But when we start thinking about how Windows works with security in mind, it turns out that that is probably not what you want just arbitrary stuff running as, right? If I were to give somebody who I knew had malicious intent, just access to my physical computer and just turn around and said, "Here you go," right? Would I want them to have a user account that is an administrator? Probably not, right? Because an administrator is a very powerful person as far as managing what actually occurs and runs on the Windows operating system. So even if I could change this type of stuff, I'm already an administrator, which means I already can do all sorts of other crazy stuff that is a lot simpler than messing around with the kernel's internal object store, right? Like if I wanted to get the flag right now, I'm an administrator. I can just open the flag, right? I don't need to trick some other process into thinking C is somewhere else because the kernel resolves it differently. Like I already have the power. And that is frequently the case when we start talking about how Windows security is modeled. Right? So why is everything an object? Well, it's because exactly what we were kind of touching on here. Their idea of how do we secure resources and how do we represent users and how do we think about administrators and who is root, right? Root doesn't exist on Windows. Like, how does this stuff work? Well, inside, as soon as you like log into Windows and you say, I am user hacker and my password is password, I'm forgetting the name of the acronym, so I'm just going to say that I know the acronym, but I can't think of what it stands for, right? Like local security, something or another. But that component of the system gives you something that is a token. It's a session token. It's an authorization token. It's an NT token. Right here, not NT object, NT token. This is the current token that I have for this session. And we can format NT token to make this look pretty. And so there's a lot of information inside a token. Did I miss the top? And this token exists, I was pretty close. This token exists from the moment I log in, right? Every session and every process has a token. And we're going to call this the primary token. See why? And so how, when I look at something in like Process Explorer, I can add a column for user, right? How do we know who the user is? Boop. For all of these processes, right? What is it showing me? Well, what this is actually resolving is what is the user of the primary token for that process. Right? Anytime that I create a process. Now, on Windows, we don't fork. Instead, we call create process. It functionally behaves quite similar, right? It spins off a process. When you create a process, it will inherit your token. Sounds pretty reasonable. A token is not a user ID. A token represents more than just that user. The user is represented by something called a SID. Next slide, we'll see what this is. And there's a rhyme and reason to this number. If we were to think about how Linux works with UIDs, the equivalent of a UID is a SID. SID is a security identifier. SIDs are not just for users. SIDs are for all sorts of security-related concepts, right? So this is a user SID. For us, we are the hacker user. There's also the SID for administrators. We see that the SID is structured a little bit differently. There's SIDs for a ton of different things. And if you, I think I linked to it. Here, maybe. If you follow the documentation, it's not literally this link, it's a link from this link. There are kind of standard SIDs. Gosh dang it. MSDN, well-known SIDs. Okay. And so these SIDs, these numbers, there are fixed ones and there are dynamically generated ones. And they can represent users, they can represent groups, they can represent levels of authority, they can represent something we haven't talked about yet, but integrity levels, right? All of these kind of like, you'll find that this is also quite pervasive across Windows as a whole, is instead of, they tend to represent things by UUIDs. Right, some universal unique number. Not only security-related items, but just most resources exist by some type of uniquely generated kind of token or name. Okay. So the SID identifies who I am. It also says what groups that I'm in. It also says like what permissions or capabilities I am allowed to do. And so the token lists all of the groups that I fall into. The token lists all of the privileges that I have. So it is possible, and it certainly happens, where I log in and this is my auth token. But what if I want to launch some process, some child process, that I don't want to, since I'm an administrator here, things are running at a high integrity level. I'm trusted. If I don't want, for instance, SE debug privilege, this is what allows the administrator, when you're in WinDebug, to debug anything on the system. It is this privilege specifically. If you are the hacker user, you can attach the debugger to processes where you are the user in the primary token for the process. But if you have the SE debug privilege, then you can debug any process that's running on the system. So what if I wanted to spin off a process that doesn't have that privilege? Well, what I can do is I can clone my token. I can drop the specific privileges that I want, and I can create a process with that new token. It's still a token that's in my name. The SID would still be me. The group would still be administrators. But that auth token for that new process I created would not have the privilege that I've dropped.
This reminds me of like syscall filter.
It reminds you of syscall filtering?
I forgot what was the
Second.
syscall. Yeah, syscall.
Oh,
Like in a sense.
if you see it, I'm just gonna, I can't run with that analogy. I'm in too deep. This gives me nightmares, right? Thinking about all of these privileges, because I need to. I know what I need. So these are privileges that are on the auth token, right? On Linux, when we think about, let's see if I can do this. Get, or what do I want? Access. Get NT access mask. Type fine. No. Dang it. Hopefully I included the command on future slide. But when we talk about all these different objects and these different types of objects, not only in Linux we say, hey, there's read, write, execute. That's all you get, right? There's like the sticky bit and like one other thing maybe that you can do with directories. It's a little bit goofy. The concept of read, write, and execute exists on Windows permissions for objects. But every type of object has up to 16, I think, custom permission access types for that type. And so like generic read is a type of access that you may be granted to a resource. Generic read doesn't actually exist. Generic read is an abstraction over whatever generic read maps to for a specific object type. So it gets even messier when we have all of these type of privileges. And these privileges we need to have in order to do something, right? But I'm going to do this, I'm going to act upon some resource. I'm going to skip the SID thing for right now. This is what I want. So in addition to my privileges, which is what the process is authorized to do on the behalf of the user, right? Every resource has an access mask. And this access mask is based upon the type of the object inside of the kernel. This is not file permissions. This goes back to inside the kernel, everything is an NT, everything is an object, right? And every object has this DAC. Now, the most straightforward thing to look at is a file. This is the thing that's going to most sanely map to what we understand as Linux. These are the NT object, or I'm sorry, NT file specific accesses that can be granted to a file object. This right here shows me that if I have generic read, right? If I open a file, and you probably did this in the shellcode, you did like create file, and you said, I want to do generic read, right? We read the create file documentation, and somewhere down here, it says you can use generic access rights, and you said, hey man, I understand open read, write, execute, right? This makes perfect sense. This is clearly working very similar. It's not, right? This is a wrapper around this abstraction. So when you say generic read, what you are saying is, I want to access or open this file with the ability to read data and read attributes, because those are two different things, right? Is there
Cascade.
map? Extended attributes, I think. Actually, no, I don't know. I'm not going to claim that. I'm not going to claim that I know that's extended attributes. But yeah, there's several individual accesses that you're actually saying you want, right? Now, it is totally possible for a file object to only allow you to read attributes, but not read the data, right? That actually makes some sense, right? At a high level, there may be a file. You can see how big it is, but I don't want you to see its contents, right? You can know about it. And we find that this kind of fine-grained access control exists for all NT objects. And I said that the access controls are different for every object. So when I say generic read means this on a file. Let's look at mutants. All right. Mutant doesn't have read data, right? So if I open a handle to a mutant object, right? I want to create a mutex. I could use generic read, but generic read is going to map to modify state and read control for a mutex.
What's a comma hole?
So there is generic all.
Oh, okay.
Right? That's actually a good observation. So I don't know if I have an example here. I don't. But there are cases, I don't know off the top of my head of one, but I know it exists, where there are fine-grained accesses that one can request that are not included in all. I bet you. What other types did we have that were interesting?
Event.
Yeah, we can look at event. Yeah, all is everywhere there. I promise you there are instances, though, objects where some of the fine-grained access controls are not included in the generic all, because when we use those generic accesses, it covers the common case, right, for a lot of people.
A hard disk is that type? What was C's type? The C code.
We can find out together.
Symlink. Symlink. I know, but like that's C's a symlink, but it itself is a hard disk.
Let's see. Oh, wait. I'm being silly. I can say get NT type.
All of
What did I just run? Get NT type access. I wonder if I can do that. This get NT.
You still need the TF for NT. For the get NT and
I don't know if this will pipeline or not. Yeah. All right. Coverage sampler. All right. I have no idea what a coverage sampler is, but I don't think opening it for read, write, all, execute will do me any good, because those generics don't apply to anything over here. I didn't know that. That was just dumb luck. But you can certainly envision that there are access types for some object type where the all case should exclude something that is hyper specific. Now, and so we now have this token that says what I am allowed to do. And then we have a discretionary access control that is tied to every single object. Okay. Then do you guys recall how discretionary access control works? It's a list of here is an access type, so and so, such and such user is allowed to do this, right? It's just a list of user access approved, user access denied, right? Group access approved, group access denied. And so in order for me to actually interact with a file or a resource or an object really that exists in the kernel, there's a lot of checks that happen, right? We haven't even gotten actually doing anything yet. We've just talked about all of the checks along the way, and we're still not done with it. Okay? I need to have the privileges to perform what I want on my token or my current process. I need to be a user group. I need to be one of the user. I need to either have my SID, my user SID, match an access I'm trying to request, or have one of my group SIDs, well, which there's more than just administrators, right? I can be in many groups here. Have one of these group SIDs grant me the access that I'm requesting. All right. So where do these SIDs come from? There's actually a rhyme and reason to it, and that's because this is a real problem in Linux that I don't know that many people are intimately familiar with. So on Linux, on my system, I'm UID 1000. You know what you are on your system?
Probably won't.
UID 1000. All right. Now let's say there's some server that is NTFS server. It's a real problem with NTFS. When you try and write a file on an NTFS server that is not your computer and it's not my computer, what UID owns that? Not a trick question. It's 1000. So then who owns the file? Is it 1000 on my system, or is it UID 1000 on your system? The answer is actually UID 1000 on that system, right? Because we don't have the ability to differentiate them. Now, there are ways to deal with this, right? NTFS has been around for a while, but the way that it's dealt with is actually by generically mapping when you connect to something as some user, typically nobody or everyone. You have a UID that is just nobody. And so all of the files that everyone can access has UID nobody. And then the system will lie to you when you try and access it. Samba or SMB does a similar thing on Unix because our ownership model breaks down, right? Because we can no longer identify who somebody is outside the scope of just that system. So Windows takes a different approach here, where our UID, our SID, conveys a lot more information than just a UID. I'll spoil a little bit here. 1000, right? This is still what we can think of as a UID, right, from Linux. And it turns out it still starts with 1000. What do you know? So what is the rest of this number? Well, the rest of this number has to do with, well, who says this is user 1000? So the SID is encoding several pieces of information. S is indicating that it's a SID. So all SIDs begin with S. The next number is the version number of the SID. So we're on version 1 of SIDs. Then you have the authority. Now, this is where who matters, right? 5 is a well-known SID. And so if I were to go back to my well-known SID here, and we look for NT authority. NT authority is S15. Who is NT authority? NT authority is the current running system, right? So who says that I am user 1000? My own computer says that I am user 1000. All right. But how does another system view that? right? Well, they may not trust my system, right? We now have some way of determining where is our source of truth. The source of truth for this SID is NT authority, the current local system. This number right here is the sub-authority. If you have something, I don't know if the dojo would have a different sub-authority in this. I don't remember if I pulled this off of prod or my local box. But this is a guaranteed unique number that is issued by the authority. I'm sorry, including the 2-1. But my local system says there's a sub-authority with this number who says you're 1,000. Now, this seems quite a big mess on my local system, right? Why go through all this noise? Well, in a more complicated environment, especially when you're thinking about enterprise environments, right? Even here at ASU, right? I log in as my name, my password into all sorts of different computers. How does that mechanism work? You think my SID exists on every single local computer on campus? No. There's a central authority, right? And so the prefix of the SID, if I were to do this, and you could do it on any of the Windows computers that you log into, you'll see that the SID has a different authority. And then that authority is the central authority that is, I determine who everybody is, right? And it would have a different sub-authority. And so in enterprise systems where you need to identify people across multiple computers, you need to log in as different people, you need to deal with accessing resources on different systems and verify. As long as everyone is trusting the same authority, then everything is correct. Right? But your computer has no reason to trust my computer because I am not the same authority, right? So we don't trust what each other say. And this is how you can end up with different SIDs where the last number is the RID, the relative identifier, based upon this authority. Right? So this authority, according to this sub-authority, which is recognized by this authority, I am user 1000. Fun fact, if I were to blow away the hacker user and create another user, this relative ID will never get reused, ever. It will always change. It will always be different because the authority will never reuse a RID. I don't know what happens if you roll it over to 10,000. That'd be the next logical question, right?
And then
Yeah, I don't know. All computers just break down. Hey, you just can't have that many users. I don't know. I would guess that they probably like generate another sub-authority because you can definitely have plenty of
what is
those.
the RID ID always for? Can it not be thought?
So the SID is, my understanding is that the SID is a constant length. We can quickly double check that. It's the beauty of linking to documentation. Boom, boom. I'm a dirty liar.
Where does it say?
It can't be a constant length because you can have a chain of sub-authorities. All right. It's a chain of it's a chain of sub-authorities. So you can have somebody blesses this sub-authority who blesses this sub-authority, right? And as long as it goes up to who we trust, then you are who you are. Where the last number is always the RID. And that's why there are also well-known RIDs for various things. Cool. So we looked at the access. We saw that generic read, generic write, generic execute is not what it appears to be under the hood. And it turns out every object is a little bit more complicated than it appears. We're not done yet. There's still one more check that pretty much everything runs through. That's something that's called an integrity level. Now, an integrity level, this it's probably the one thing that makes the most sense and is the most straightforward. I'm not saying that the other stuff doesn't make sense, but it's quite complicated, right? It gets very dense. That's why create file has so many arguments, right? Because I have to specify what kind of access is it, what's my token, what's happening, right? There's all of this stuff that needs to be checked and configured in order to just open a file or access a resource. Integrity levels follow kind of a straightforward series. I think there's one more I didn't list here of integrity levels, which is how much do I trust this? Okay, it's not just for tokens, but this, I'm going to say resource, but it also exists on tokens, access tokens. And so we have unauthorized, low, medium, high, and then system. When you log into the Windows system and you are not an administrator, you have an integrity level of medium. When you log in as an administrator, you have an integrity level as high, which we saw when I looked at the current running off token. Why have this additional check? Well, we think about on Linux, I could be root. I'm editing a configuration file, right? And I save this configuration file, but I make it readable to everyone, right? For whatever reason, I done goofed. Integrity levels mean that even though I goofed and I made it so that everyone could read this file, if you are not high integrity, you still fail the check. So if I were to, when we could do this, I'd have to restart the VM a couple times.
The config file is high integrity.
Yes,
Because a root changed it, or because the file is itself
because
has high integrity?
the file itself has high integrity, but the file itself, well, it had high integrity because it was written by if it was created with a high integrity token, right?
No, doesn't matter what the user is. The token that was
What matters is the integrity level of the resource.
the process that made.
So if we were to look at did I have enough? If we were to look at, we'll do it in the GUI. Give me some random file. The flag is probably high integrity. We go to C, and everything that I'm doing in the command line is accessible via the GUI. And in fact, in many cases, the convention is to use the GUI, and the resistance of using the UI is me, more than anything. And so if we go to security, we see that it's accessible to administrators. And if we go to advanced, we should see, it doesn't show it. It would have an additional line that says integrity high, which is unfortunate. It's not there. But this is owned by system. Bam. But the files themselves have an integrity level tied in. And so there could be a file, we could create a file that is, everyone can read it, but its integrity is high. And if I were to log in as a regular user, my token, my access token, that everything from me logging in is a medium integrity, I would not be able, so I may be able to read. By default, I would be able to read, but I wouldn't be able to write. So it's strange.
You wouldn't be able to. It's your medium.
No. So you would think that, right? This is why while I was making this slide, I almost said that it follows, what is it, Bell Padula? But it's not quite Bell Padula because the default is not exactly the same. So if we were to look at this, it's going to say Where is it? Yes. By default, the system creates every object with an access mask of mandatory no write up. But there is a no read up. But that is not the default mask for integrity levels. So what the integrity level is by default is preventing is if a administrator made a file read write to everyone and some unprivileged user who, according to the DAC, I have read and write permissions, right? But I'm not functioning at a high enough integrity level, then I would not be able to write to that file. Because by default, the only thing that the system enforces is write up for the integrity level. You cannot write up. So I can't be medium integrity and modify a resource that is high integrity. I can still read it. Now, we could change that. I have so many freaking MSDN tabs. If I were to find, it's the right one. If we were to add the system mandatory label no read up, then the integrity level would also prevent reading, but that is not the default.
So, but if you made a file read write executable library, someone of the lower integrity level can execute it because there is no executable.
Correct. And this is where I wouldn't blame you for thinking, well, can't I use integrity levels to like replicate SUIT? I could have this like high integrity executable file on the system, right?
Depends on its I'm liking all the session, the thingy, the authorities. What was it called? Authority
token?
Token, yeah. Depends on the authority token it has.
Right. The authority of the file resource. So like if I have an executable file sitting on disk that is high integrity, my token is medium integrity. I start that executable. What is the integrity level of the process and why?
It's my token.
It's right. It's my token's integrity, so it's still medium. The resource has high integrity. My process is based upon my access token, my authority token, not the authority of the binary, or not the integrity level of the file itself. This is enough where we can start thinking about how Windows security works and why we have, for instance, that flag service, right? Why do you have to open this weird pipe? Because all of this sits in the middle of normal interaction. And so if I want to just have you mess around with binaries and thinking about what happens in the assembly, let's try and make the rest of it really simple. Okay. Any questions about what was discussed here? So I didn't.
I think you've already said this either today or last week.
Mm-hmm.
Who issues your authority token?
Like when you log in? Yeah. Okay. So when you initially log in, let's see if I can see the process itself. It should be called LSASS, if I remember right. Oh, I'm using the GUI. Everyone should be so proud of me. This guy right here. The local security authority process. This is the process that actually gives you your token.
And does that give you a token every time is it one time when you create the user, or is it every time you boot the system up?
So the token is generated when you log in. So like if you're at a Windows terminal and you type in your name and then you type in your password, you hit enter, the token is generated. It's not like generated because the token itself doesn't like sit on disk, right? The token is a real-time thing.
It's something to your object. It's an object.
The token is there is an NT object that is the token. That's why I can say get NT token. Format NT token. Get NT. Get NT token. Format NT token. T. Whatever. I can do this, and it will give me everything that is in the token. It just won't be pretty. So what was the original question? Oh yeah. The token is an NT object. That was where we were. So the token is an NT object type that is generated by the local security, whatever the heck it was, local security authority process. When you log in, it is what is creating your session, and it creates your session, or it's the one that gives the token that is your session.
And does this issue all tokens or just my token when I log in?
Well, once I have my token, right, when I create a process, it will inherit my primary token.
But what if another process exists with some other token that I didn't interact with? Where does that token come from?
All tokens come from, so all of the initial tokens come from the local security service. But
any subsequent tokens are from processes.
Any subsequent tokens
inherited.
are inherited or they are duplicated. So if you look at MSDN, is it duplicate token? This is what I'm going to demo off stream because it's going to get quite spicy. Is you can duplicate your token, and then I said that you can drop privileges, right? Well, there is a privilege that we have on here. It's going to be SE impersonate. It's hiding in here. But SE impersonate allows things to, as the name implies, impersonate another user. And so what you can do, if you're like, okay, what is the name of the game? How do I get privilege escalation on Windows, right? I am given a token. I am the lowly hacker user. How the heck do I become admin, right? There is no sudo. How do I do this? I can duplicate my token. What's the new token? The lowly hacker user. That's no good. Can I duplicate somebody else's token?
Well, they have to duplicate that.
Well,
who's going to call duplicate token?
Who's going to call duplicate token and just give me their token, right? Like that isn't a normal thing, right? Because in Windows modeling of permissions, if I'm the lowly hacker user here, and I need to perform some action that requires more privilege than I have, the kind of Windows philosophy is there should be a privileged service running that you interact with. The service does something for you on your behalf. You never get to power up, right? The administrator logged in separate from you and created a service to do this nice thing for you. And that is all you are allowed to do is talk to this service that then does some action. And so the things that are elevated, right, that are interesting are services.
Those are the only types that have elevated, or
Well, it's entirely up to as far as like what you commonly will see on a system, right? Well, what you're typically interested in is something that is running as system, running as admin, could be running as a dedicated service user, right? I don't know what the privileges that are on some random service token are, right? We'd have to look at it. But what you're looking for from a target perspective is some process that you can interact with that has a token that is more powerful than you.
and see if it has a vulnerability.
Yes.
Okay, so where does the local security authority pull information to give me my token? Like, what level of authority do I have?
So I'm going to just call that one a black box for the purposes of today. Off stream, I'll comment a bit. I don't want the internet to hear whatever dumb is about to come out of my mouth. Because I'm sure someone could correct me, right? I am not an expert in this arena. I am learning and enjoying it and passing on these wisdoms. It's a good question. I'm not. I'll say this on stream. I'm not 99% sure, but I'm pretty sure that. Pretty sure someone can tell me I'm wrong, so don't hold me to it. That this is running in the secure desktop, which is something that we haven't talked about either. I think last week I referred to it as the secure session. It wasn't the correct terminology. There is like your login. I know your login, the program that is your login runs in the secure desktop. The secure desktop is like a completely isolated world from everything else. I don't know of any way to show you that they are in fact separate desktops. And there's two things that I know run in the secure desktop, and I would bet that this guy does as well. The login screen runs in the secure desktop, so it's isolated. No one else can really talk to it, touch it, do anything. And then the U8P, that nice little, I right click as administrator, the box pops up and says, hey, do you want to do this? That process or that interaction also happens in the secure desktop, which is completely isolated from everything else that's running on the system. It's the whole reason that checkbox actually works as a verification mechanism, right? Otherwise, there'd just be some process just chilling there. And yeah, we're just going to call that and click yes for you, right? We could automate that. But Microsoft, kind of thought about that a few versions ago. And so I would imagine, I'm definitely imagining that the same would be true for that guy. So there is a question from Twitch. It goes back a little bit here. They say, does integrity supersede the access token? If a resource has been created with minimum system integrity, is it possible for the system user to give a token for an admin to access the resource? Okay, there's a whole lot of words there. Okay, I'm going to read it one more time. And I don't blame the question asker here. It's legitimately just like a complicated thing to discuss as far as terminology goes. So the full thing is, does integrity supersede the access token? If a resource has been created with a minimum system integrity, is it possible for the system user to give a token for an admin to access the resource? And I know what my response would be. There's going to be some actuallys in here, but anyone think they have a take on?
So I'm gonna mess up the terminology.
All right.
So this resource has low integrity.
Right. I've got a resource. We can just say it's a file, right? It makes
File has low
concrete.
integrity.
There's a file that has low integrity.
Someone gives it a high, gives it a token with different with. Well, what's in the token?
Well, this is where the terminology falls apart.
Yeah.
In the question, and so there's a little bit of misuse on terminology. If you want to rephrase, I'll answer, because it falls apart when we say, is it possible for the system user to give a token for an admin to access the resource? And so tokens are not given from users to users, right? Tokens are something that I just implicitly have as a running process that I can duplicate. And I can also, we're just going to go with that. Primary tokens is all we're talking about. And primary tokens are something that implicitly exists from the moment I log in the login session. Every process that is created uses the token that I logged in. Right? The system user doesn't give me a token. And so that thinking or framing of things is not accurate. The resource, to the question of the file and integrity. If a file or a resource is low integrity, and I'm medium integrity because I'm just the lowly hacker user, right? I would pass the integrity check, right? So then the next question is what are the access checks as far as discretionary access control is concerned? And discretionary access control, if you'll recall, is where we did this right here, literally this command. So I'd be looking at, in the discretionary access control for a file, which I wish I knew the command for the terminal, but I don't remember it. You're looking at the same thing, though, when you look at this. This is a graphical representation of the DAC. And so the only thing on the flag is administrators have full control, modify, read, write, blah, blah, blah. But if I wanted to, we could add something to this. I want the hacker user, and the hacker user can read, but not write. Okay. Graphically, in the UI here, I have now added a new entry to the DAC for this resource, which is a file, right? And so when the hacker user tries to open this file, what it literally is just going to iterate through, am I this person that's allowed? No. Am I this person that's allowed? Yes. Do I pass the integrity check? Yes. One does not override or overrule the other. They both must be satisfied for, by default, writing. So I guess this would be a bad example. I'd want this there. So now the hacker user, according to the discretionary access controls, can read and write.
I also see there's an allow and deny.
Yes. So you can discretionarily deny somebody. I will say that.
How is that different from not allowing?
So you could envision, I have a group named students. You all are students. However, Tom, right, is a bad student. And I don't like Tom. So Tom can't access, my helpful guide. And so how would I represent that in my DAC? I would say students, which is a group, allow reading. Specifically Tom, well, F that guy, right? Deny him. Now, in practice, that isn't something that you want to do. Deny rules can be tricky because you do not have, my understanding, I haven't proven this concretely, but my understanding of how the DAC is iterated for these permission checks, you do not have a guarantee that denies are checked first, right? So there is an order in which you would envision that you're writing this check, right? It's a for loop, and you're saying, hey, is this you? Yes or no? If the denies aren't parsed before the accepts, right? and you found an accept, you could short circuit, and somebody who has a deny can be accepted. And so they do work, but you can't just like arbitrarily throw on a deny because it can get parsed in the incorrect order and not do what you expect. There are probably smarter people than me that know exactly how to reorder that. But I know that that is a thing.
I'm just curious because the GUI doesn't make this clear, but can I press allow and deny on the same thing?
Let's find out. Bam, bam.
No, okay. It looks like you can.
Let's see, read and execute. So they do seem to supersede each other there a little bit, at least as far as the literal entry for a user. But a user can be a member of many groups, right? So what is the intention, right? It's unclear. Imagine that I am a student and I am a TA, right? Well, TAs are allowed to do something, but students are denied. Well, I'm both. Should I be allowed or should I be denied? Depends on how you interpret it, right? And so it's not necessarily a flaw of the system. It's a flaw of how we think about defining discretionary access control rules, right? There is an order, there is a rhyme and reason there is a difference between defining one rule than another. The same thing's true if you ever do a firewall. If you've ever done that. Very similarly, like you have this allow, deny based upon some condition, and the order in which the rules are stated are mission critical. Twitch says, I worded my question very confusingly. Sorry, it's late. Thank you for answering. I'm more than happy to give it a shot. It wasn't that bad. All right. Anyone have any last minute things on stream, Twitch or you? If not, I'm going to off stream talk a little bit about impersonation, which, for the record, if you are not here in person, there will be a pre-recorded lecture video that discusses it, so you aren't like when the challenge come out that discusses this concept. But the live demo is guaranteed to be a dumpster fire. So we'll save everyone the pain and me the shame of having it on the internet. Anything else? Beautiful. All right, Twitch, I appreciate you hanging out. Hopefully in a couple days here, I will have some live challenges that play around with this stuff. It's going to be a lot more interesting because the flag service that you guys have relied upon will probably not be there for a lot of these challenges. That's why it's very interesting to like stand all this infra up, because there's all of these mechanisms that I discussed at play for how do you get the flag. All right. With that, I'll leave you. Goodbye. Good luck. I'll see you next week.